Alright, we're talking about the properties of limits here. These are some pretty basic properties. They're really pretty simple. And they kind of follow the same rule as any coefficient or any term in a normal algebraic expression. So let's just go over them real quick. These are just kind of fancy ways of writing out exactly what we're doing here. So let's say we're asking for some limit of an expression with a coefficient out in front. Well, we can bring that coefficient out in front of the limit sign and multiply it through because it'd be the same either way. And so that's going to help us simplify some problems. Same with the sum and difference property. If we have a function plus another function or some expression plus another expression, we can write it as the limit of that expression plus the limit of the second expression. So we can break that into two limits. The same thing with minus as well. Same thing with product. So for multiplying, we could separate that out. So if this was the limit as x approaches a of f of x times g of x, we can make it the limit as x approaches a of f of x times the limit as x approaches a of g of x. So we can separate into two limits. And finally, the quotient rule, we can do the same thing. So if we have the limit of a function over a function, we can break it into two different limits. So those properties really help us. There's also a power one that I'll show you later on in the notes. But those help us really simplify some limits and solve some more complicated limits. So let's go to that. Oh yes, here's the other one, the power property. So if you have some limit of a function to an exponent, you can actually remove the exponent to the whole thing and just evaluate what's on the inside here. So pretty neat, pretty easy stuff. So these ones just say to rewrite using scalar multiplication. I'm going to do the version A's, and then I want you guys to just try the version B's on your own. So this first one, pretty straightforward. I got a coefficient of 7, so I'm going to write 7 times the limit as x approaches 3 of f of x. That's it. So why don't you go ahead and see how you could rewrite version B there, and then unpause the video when you're ready to check your work. Okay, I wrote it two different ways because there's actually two different ways you could write this. Both we would bring the 7 out, and that's fine. But because we have a power of 17 here, once we bring the 7 out, we just have the limit of x to the 17, like this. Well, that means we could actually take the 17 on the outside and just take the limit as x approaches 0 of just x. You could do that as well. So, again, we're not solving these, we're just rewriting them. That's all we're doing. If you were to solve this, you could see really quickly that you would take x as x approaches 0, you get 0 to some power is still 0, times 7 is still 0, so that would be 0. Okay, let's go to the next one. This says rewrite using the sum or difference property. So we can see that we have the sum of two things. So we could write this as, and I'm going to bring the 4 out as well. So I'll show you how we could rewrite this. We could write this as 4 times the limit as x approaches 2 of x squared plus the limit as x approaches 2 of 3. So that's totally fine, and then the cool thing here is that this is actually just 3 because there's no x in here. So even simpler, you could just write it like this. And this, I guess this is kind of evaluating the limit here, but it's just showing you that you don't really need the limit notation for everything. So that, again, that limit notation is now just for the x squared. And again, I could even pull the square out too. So kind of neat what we can do there, as long as we apply that limit sign to everywhere that we put it. Why don't you guys try version here on the next page. Okay, so again, I pulled the 2 out, then I got the limit as x approaches 0 of just x. Then I got this minus 4, so I'm going to subtract the limit as x approaches 0 of just 4. Now again, there's no x here, so this is just 4. I could have just written this like this. Maybe I'll put parentheses here so it's a little bit easier to see what's going on here. We could write it like that. That's fine as well. Alright, the next one's talking about using the product property. So if we were to rewrite this, it could be 4 limit as x approaches 2 of x, and if we wanted to, we could even bring that square out here, times the limit as x approaches 2 of 2. And remember, I'm kind of evaluating here, but to show you some of these steps, you could write it like this. And then this is kind of a neat one because you get 2 times 4, that's 8, and then you could plug that in. So let's just solve it real quick just so you can see. You end up with an 8, because 4 times 2 is 8, and then you end up with, if you plug a 2 in, you get 2 squared. So you get 8 times 4, which is 32. Pretty cool. Okay, last one, rewrite using, actually I'm sorry, it's not the last one, but almost the last one, rewrite using the quotient property of limits. So, a couple things about this is you could reduce and everything, but let's just rewrite it. Let's just say this is the same thing as the limit as x approaches 2 of 4x squared. And if we wanted to, we could actually put the 4 on the outside. Don't need to put it there. Over 2 times the limit as x approaches 2 of just x. And we could actually simplify things here. Not really necessary for this problem, but yeah, we could cancel out a 2, we could cancel out an x, all kinds of stuff. But just showing you how we could rewrite it. Let's go to the next page. Okay, it says rewrite using the quotient property, but I'm pretty sure they meant to put power there, so let's go ahead and do that. If we rewrote this using the power property, it would look something like, now I can't pull the 10 out here because it's inside of the square. So this may be a common mistake. Let me just show you what you cannot do. This is not the same thing as 10 times the limit as x approaches 1 of x squared. That's not the same thing. Now, if I was to move this parenthesis out here, then that would be okay. So, just to make sure you understand, right, because that 10 is inside the parentheses, and that's very important that we keep it inside there. It's being squared. If you were to square everything first to make it 100x squared, then you could move the 100 out, but just making sure we understand how this works. So if I was to just use the power property, it would just look like this. The limit as x approaches 1 of 10x squared. And then that ends up being, another way you could have rewrite this, like I was saying, is you could have said, well, this is the limit as x approaches 1 of 10x squared is 100x squared. And then you could have written it as 100 limit as x approaches 1 x squared. Hope you guys are understanding just some of these properties here. It's basically just as long as you're using order of operations and putting that limit sign anytime you create a new term or separate terms, then you should be fine. So again, those are your properties there. Pretty straightforward. See you guys in the next video.